In this video, we'll be looking at the basics of how to use Matlab in a signal processing context. What you're looking at here is your basic Matlab installation. I installed Matlab and I ran it, and this is what it looked like when it came up. So I want to draw your attention to a few things and then we'll get started. The first thing is that there's a variety of different windows. So we have the current folder window, the command window, the workspace window, and we'll see what each of those does in turn. The command window is sort of the main place. This is where you can type in individual commands into Matlab. For example, you could say something like x equals 1. And when you do that, Matlab takes the value 1 and assigns it to the variable x. And you can see that that's now in your workspace. That means that that's in Matlab's memory. You can also see that it has verified that the command was good by echoing the value of x in the command window. If you say y equals 2 with a semicolon after it, it does the same thing. It takes the value of 2 and it stores it in the variable y, but it does not echo the results to the screen, which is nice. It just keeps things a little bit more compact. Finally, one thing that's really nice in Matlab is that a variable doesn't necessarily have to just contain a single number, but it can also contain an array. So for example, I could say z equals 1:10, and you'll see that z is now a variable that contains 10 values, the numbers from 1 to 10. And if I really wanted to get crazy, I could do something like w equals 0:0.25:3, and you would now see that w contains the values starting at 0, incrementing by a quarter, going all the way up to 3. Okay, so this colon notation lets you build an array with evenly spaced values the way that you like. Okay, now if my screen is a little crowded, I can always type the clc command to clear it. That just clears the command window, but it doesn't clear memory. If you want to clear memory, you have to type clear, and now you can see your workspace is empty. That means you've erased memory. So let's go ahead and create a plot. So the first thing I'm going to do is I'm going to get out of the habit of typing my commands directly into the command window. It tends to be pretty inefficient, and you also cannot save things. So for example, now if I wanted to recreate the variable w, I would have to retype it from scratch, which is inefficient. So instead what I'm going to do is I'm going to type edit, and that's going to bring open an editor. So an editor is basically just a text file, and in the text file I can put whatever commands I want, and then I can run the contents of the editor. And when I run the contents of the editor, I can go back and make changes to the edited file and rerun it without having to type all my commands in from scratch. So there's some nice efficiency there. So let's give it a whirl. Good practice is always start my script with clear, so I know I'm starting with a clear memory. And let's say that I'm interested in plotting, let's come up with a cosine. Let's say I want to plot cosine of 2 times pi times 500t. Okay? So that's what I'm trying to plot. So let's see how we actually go about doing it. First thing you should notice is that when I use this, when I start a line with a %sign, that line becomes a comment, which means it's useful for the reader, it's user readable, but it doesn't actually get executed by Matlab. So that's just sort of a note for me to know what I'm trying to do. It makes your code a lot more readable to put comments in. So the first thing we need to do in order to create this plot is to define my independent variable t. So I have to do t equals. And I have to put a little bit of common sense into thinking about what range of values I want for t. So let's say I want to start at time t equals 0 and go to, I don't know, t equals 1 second. And let's say I'd like to have 1,000 points in there. So I don't know that this is right, and we'll come back and revisit that in a minute and see how good this guess is. This is also going to create an array t with a bunch of values in it. It's a little bit different than that colon notation we looked at before. It's not like there's a right or wrong way to do it. This is just a different way that I like to use. This command will give me 1,000 evenly spaced points starting at 0 and ending in 1. So it will basically work out for me how big the time step has to be between each point. Okay, and if I run that, if I come over here and I hit run, actually before I can hit run, I have to save it. And before I can save it, I have to decide where I want to save it. So let's take a quick detour and figure that out. You'll notice this window up here shows what's called the current directory. And if you save a file, that's where the file is going to go. So I don't want it to save in Documents Matlab. That doesn't seem like a very ideal place for me. So what I'm going to do is I'm going to change to the desktop, and I'm going to go ahead and create a new folder called My Files, or whatever you want to call it. And now you can see that that's the current folder, and that's now when I hit save, that's where my files are going to go. So let's hit run. I'm in My Files. I'm going to save it as example 1. Okay, so now I have a script called example 1, and I can run that script. And when I run that script, you can see that now I have a variable t in memory, and that variable t contains 1,000 values. And if I want to look at what those 1,000 values are, I can double click on t, and it will pull up this this little spreadsheet looking thing, and I can see that the first value of my time is 0, and 0.1, sorry, 0.001, 0.002. Well, that seems like a pretty inefficient way to go across the array. Let's scroll. Alright, and you can see that I have exactly 1,000 points, and that the final time is 1 second. Okay, so that's good. Now I have a time, I can create a signal. So cosine 2 times pi times 500 times t. And what that's going to do, if I run that, is it's going to create a new variable x, and x has the same dimensions as t. So essentially what it's done is it's going to go for every single element in t and calculate 2 pi 500t for that specific value of t. So if t has 1,000 points, x has 1,000 points. And finally, I can create my plot. So plot t comma x. Okay, that's the notation. Let's run it, and voila, we get a mess. Okay, so let's park that. I'm going to move it. Oh, one thing you'll notice is that all your windows in Matlab are movable. You'll get used to this. You can drag them around, put them wherever you like. It's all kind of infinitely customizable. So something is not quite right here, and I think the problem is we didn't quite put enough points in here. So let me up this to 10,000 points, and that looks better. There's actually, really, you're just limited by your computer's memory. You can even go something crazy like 10 to the 5th points, and that's going to be a little bit nicer. Now, right off the bat, you can see it looks like I put too many points in my plot. Okay, if I click on the figure and I get this menu, I'm going to select the zoom button. If I start to zoom in, you can see, boy, did I get a lot of periods. I mean, the good news is it is a cosine. Okay, we can see that, and that's nice, but I did not need that many iterations. In fact, it's a 500 hertz cosine. That means it's going to iterate 500 times per second. So in a second's worth of time, I'm going to see 500 cycles, and that's just way too big of a mess. So instead, what I'm going to do is I'm going to zoom in on let's see if we can zoom time in a little bit. So one thing I could do, will be a little bit clunky, is I could just go and change this to some other value, like 0.1, and that's still a little better. There you go. So now it's kind of coming down to something that we want to see. So I only need about that much time, 10 milliseconds worth of time. Then I get to see 5 cycles. Everybody's happy. Now, there's nothing wrong with that, but there's a better way. A slightly more efficient way of doing this would be to come along and create a variable f equals 500. So let's store my frequency as a variable, and then let's define the period. Now the period is by definition the reciprocal of the frequency. Okay, now when I do this, t will be calculated automatically for me, and I don't even have to worry about the value. You'll notice that I'm never even going to see the value of the period. So now when I come and I create my time vector, I can say start at time 0 and give me enough for, let's say, 3 periods. Okay, give me 100,000 points starting at time t equals 0 and going out to 3 periods worth of signal. Okay, and then here I can replace that with an F, and it'll work perfectly for me. So the nice thing about structuring my code this way is that I don't have to worry about calculating the actual time value. I let the computer do it for me. Alright, finally, just as good practice, it makes always sense to comment your code. So frequency in hertz, time in seconds, 3 periods, and that's also in seconds. Let's see if we can pull a little bit more of that on the screen. Alright, there we go. Define the cosine, create plot, and then if we really want to get crazy, we could do something like x label time in seconds and title my first plot, and now our plot is ready to go. Pretty convenient. So in future videos we can show some new features in Matlab, some ways of improving the plots, but this should be enough to get you started. Let me give you one final piece of advice. You can see on the x-axis my time says 0, 1, 2, 3, 4, etc. And then down here in the bottom right corner it says times 10 to the minus 3. So that's how you know that this 1 doesn't mean 1 second, it means 1 millisecond. But that 10 to the minus 3 can sometimes be a little bit challenging to spot. So there are a couple tricks we can get around. With. One way we can do is, instead of plotting it versus time, we can plot t divided by a millisecond. So in other words, we're going to divide a millisecond out of every term. So 1 millisecond will now just be 1, 2 milliseconds will now just be 2, and so on. Alright? And that'll work. All I have to do now is change my my x-axis label to say milliseconds. Okay, and now it's a little bit more obvious because the label is in the x-axis. So 1 millisecond. Okay, and now you can see I don't have the 10 to the minus 3 here anymore. There's no right or wrong way. It's not like one is right and the other is wrong. It's just partially a matter of style, but it always makes sense to think about making plots that are easy for your readers to digest. So we can save this and quit, and that's how we do our first MATLAB plot.